Oh, there, this is exercise 4E.2. It's linked to what we were doing before, in as much that we've got normal distributions to approximate discrete distributions. That's exactly what we were doing with the Wilcoxon stuff. But this is subtly different because the types of distributions you're going to be playing around with are ones which aren't necessarily quoted in the textbook. But then I've seen some questions in the exam, so that's why this has appeared. So let me just set the pen for use, and then we'll get on. And so just be aware then, this is meant to be a binomial distribution in green. But just look how normal it is. And if I had the software working here, I'm not going to run it because if I had the software working here, I could change the p or change the value of n. And essentially, as long as n is big enough and p is roughly in the middle, you get an approximation which is broadly right. It looks broadly normal, as that picture kind of suggests. So the conditions that we need to be true in order to use the normal as an approximation for the binomial. I've written it down here. It says the parameters n and p are, if p is roughly equal to a half, so roughly equal to a half, that roughly is an interesting word, and n is large. And again, how big is large and how roughly equal to a half does it need to be? So here's a little trick that we use, and I quote this in normal maths as well. We don't really need it for normal maths, but I think we do need it for further maths. And I just would say to you, if n times by p is bigger than 5, and the other end as well, n lots of 1 minus p is bigger than 5, and that is a general rule. Y5, it's like a made up number, but if these two things are broadly true, then we are allowed to use a normal distribution to approximate the binomial. Don't forget continuity corrections. I talked about this last time, and we'll do it again here. So the discrete random variable x has a binomial distribution. Now, so we're saying x is binomial, n is 100, and p is 0.4. Now, one thing you should know about the binomial distribution is that when you, and these are in the formula books, but the mean for this approximation to take place, mu equals mp. And the second one is that sigma squared is np 1 minus p. Now, we will need to use these two formulas, which are in the formula book, as I say, but not necessarily obvious. So in this case, if I approximate this 100 times by the 0.4, you can see that x is broadly normal, and x times 0.4 would give me 40. So I would expect to get 40. Now we've seen that NP trick load, so that's not a surprise. The sigma squared bit, I'm going to have to type this into my calculator. So I've got n times p, that's 40 again, times by 1 minus p. 1 minus p is 0.6. So I get 24. So my variance is 24. So put a different way, there's my normal distribution. I'd expect to get 40, and therefore what's the probability in 50 or under? I actually want this. Now be warned, we don't use the 50. I want 50 or under. So I don't want 50, I want all numbers lower than that. So I'm actually going to have to use 49.5. Now that's not as obvious as you might think. Last time we always went in, didn't we? If that had said less than or equal to, I would have needed to include the 50, and therefore I would have gone the other way and used 50.5 and under. But as it happened, I don't need to worry about that. So to do this, I'm going to, in my calculator, work out this probability. Again, I'm going to use 49.5. X is less than 49.5 is what I'm typing in. And let's see if I can do this. Normal approximation. So menu 7, I'm going to norm CD. Now, I'm not touching the binomial because it says use an approximation. So the lower one is negative 99999. The upper one is 49.5. Sigma is the square root of 24. And the mean is 40. So if I just type that in, I get 0.974. Hopefully that's what I've got on the other one. And over here it's exactly the same thing, greater than 50. Well, this is interesting in itself. You'd think almost it would be 1 minus it, but greater than 50. This is all true still. I expect to get 40. There's my 50. Greater than 50. I don't care about the 50, so actually I'm going to use 50.5. So the probability that x is greater than 50.5. So these continuity corrections, here was meant to be 50, but I went that side. I didn't want the 50. So let's just type it in. This time it's 50.5 for the lower, 9, the upper. The mean and the other one should and the mu should not change. 0.0160 to 366. Let's see what the answers are. Yeah, so I've done it to 4dp, but you can see those are exactly the right answers. So we're going to have to be careful. Using a suitable approximation. This is exactly the same, but now do 2 other questions. So right, I could have done that on that. So I've got, I just remember those numbers, 40 and 24. So I've got, where's my pen gone? There it is. So I've got x now is normal, 40, 24. And it says what's the probability of being less than or equal to 45. So all this is about is trying to get you to understand how to decide. Now 40 is there. There's 45, a bit to the right. But I want it says less than or equal to 45. So this time I've got to go slightly this way. I'm going to use 45.5 because of the equal sign. So the probability then of x is less than or equal to 45.5 with the continuity correction in place. Let's do this. So my lower now is negative 999. My upper is 45.5. The other 2 bits I think stay the same. So I get a value here of 0.869. Equals 42. That's an interesting one. So what do I expect to get? I expect to get 40. And I've been asked to calculate the probability of 42, but it's equal to it. Now, if you ever get one like this, really go a little bit to each side. So this is really the probability that x is between 42.5 and 41.5. We go a little bit above, a little bit below. So actually it's easier than you think. That one, 41.5, 42.5. I've seen other textbooks which say this is equal to 0. I can't remember actually now I've done this, whether or not I'm meant to write 0. Certainly AQA, when they do this, this is what you're meant to do. And then when they ask you this question, you go a little bit either side. I vaguely remember OCR actually now. I wish I'd checked this PowerPoint before I did it. I vaguely remember now some of those just saying the answer is 0. And they don't do any of this stuff. Let's see what the answer is according to me anyway. Oh no, good. Oh, I'm pleased by that. So, and that's what I've got when I've just pressed 0. I've got 0.0748. Good, I feel better now. So they are doing this rule that in OCR that you do this. You go a little bit lower and a little bit higher. It's always the same amount of the continuity correction both sides. Add a 0.5 on, take a 0.5 off from the number you got given. I feel slightly better. This is an exam question. A fair dice is thrown 90 times, so fair, so therefore it's binomial 90,16. Use an appropriate approximation. You need to know to use the normal. X is normal. Remember you do n times by p. That's 15 if you do 90 times by a 6. And np times by 1 minus p. I'm just doing that now. 1 minus p is obviously 5, 6, and I get 12.5 when I do that. So that's my variance. And it says find the probability that the number 1, which is a 6, is obtained 14 or more times. Now remember, I'm doing this 90 times. I expect to get 15. What's the probability of getting 14 or more? Now, 14, I want 14, so I just need a little continuity correction. So I'm going to say x is greater than 13.5, and that's my continuity correction. I wanted the 14, so I had to include it. If I'd used 14.5, that's not including it. So I have to go this side of it. So I'll chuck that in my calculator. That's an old question we're looking at. It's 6 marks this. So menu 7, norm CD2. So what we're doing, the lower is 13.5, the upper is lots of 9s. Let's go back. Sigma, what was sigma? It was the square root of 12.5 and the mean was 15. I get 0.66 in a bit. What is it? 0.664. Let's see what the answers say. 0.664, there you go. Sometimes we have to do Poissons as well. So it's a similar trick. The Poisson, the rule says you can do it as long as lambda is more than 15. As lambda is more than 15, you're allowed to approximate a Poisson with a normal. Remember, continuity correction. So exactly the same thing. We've got this here, that lambda is 30. Now the nice thing about this is therefore x is normal 30, comma 30. That wasn't that weird. Mu is 30, and it's the sigma. Well, I'm going to write sigma is root 30. That's the important thing to note. So here I'm doing this here. There's my 30. The first question says, what's the probability of being less than 20? 20 is all the way down there. Less than 20. Oh, notice I don't want the 20. It's not equal to. So I'm going to use here the continuity correction. X is less than 19.5. If I type it into my calculator, menu 7, 2. The lower is lots of 9s with negatives. The upper is 19.5. The sigma is root 30. And the mu is 30. And I get an answer there of 0.0276. So you can see now these are all looking a bit, I'm going to write 15 here just to save me rewriting or redrawing it. So this time I want greater than or equal to 15. Notice I want it to be equal to 15, so my continuity correction has to include it, so it has to go to the left of it. So this is actually the probability that x is greater than 14.5. So let's do this time this then. So the lower is 14.5, 9999 for the upper, and I get here quite a large probability, 0.998. And again, this equal to 30. We've seen the trick here now. We basically are going to do x between 30.5 and 29.5. A little bit more and a little bit less. So if I do that, 29.5, there's the lower, 30.5 is the upper. And I get for this one 0.0727. And it even works. What about this? Now notice then in summary we've got 4 different potential approximations. That's what the title says underneath that. 4 approximations. We've got the one that I've just done, the binomial, and you'll notice on this slide it tells you the formula to use. Mu equals mp, sigma squared equals that, and we can use it as long as mp is more than 5, and then q is a quick way of writing 1 minus p, and 1 minus p is more than 5 as well. The Poisson we just saw, we can use it as long as lambda is 15 or more. And the nice thing about this Poisson is no calculations. The mu is lambda, the variance is lambda, therefore the sigma is root lambda. And we saw in the last slide the Wilcoxon signed rank with these 2 horrific formulas for mu and sigma squared. And likewise Wilcoxon rank some 2 not overly nice formulae. But you don't need to learn them, they're there for you. The trick is to practice them and use them. Then hopefully you'll be alright. Now the only other job I want you to do is to go and have a look at exercise 4E and mixed practice 4 as well. It could be, try to do them all in there, as many as you can at least, and a nice variety of questions. And if we get any of these questions in these ones here, if you get any of these, brilliant. If you don't worry about that so much. We'll see some in the exam questions as well. So thank you very much and best of luck.